The Kunsthal in Rotterdam is designed by Rem Koolhaas and was built in 1992. The building is located in the south of the museum park, in between the center of Rotterdam and the river Maas. Base of the design is a square box of 60 by 60 meters that is crossed by a road and a path for pedestrians. Inside the building we find 3 exposition halls, an auditorium, a restaurant and offices. The main design concept is the continuous route through the building that connects the exposition halls and the auditorium. For this case study, we zoom in on the auditorium that is situated on the first floor. The auditorium has a fully glazed façade that is situated to the southwest. This gives the auditorium a lot of transparency. The auditorium has 4 major problems. Problem 1. The Kunsthal has a heat loss problem. This is because there are a lot of thermal bridges and the use of thin double glazing. Problem 2. Solar studies show that the southwest facade is highly overloaded with solar radiation. This solar radiation overheats the space, and besides that, it brings unpleasant bright light that causes a lot of glare. Problem 3. The open connection of spaces through a museum causes a ventilation problem. Problem 4. And last, the entrance is situated next to the auditorium and visitors have to walk through the auditorium to visit the museum. After looking at the problems and linking them to the transparent west facade, we came up with the following research question. How can the west facade of the auditorium be redesigned in a way that the space will be better suited for its intended function while maintaining the advantages of having a transparent facade? To answer the research question, we came up with 3 design solutions. In the first proposal, the auditorium is separated from the facade using a box-within-box principle. The reason behind this change is that the climate control and the use of the lecture hall can be independent from the rest of the building. The second proposal is to make a double skin facade with solar shading devices in the cavity. During the summer, heat will be ventilated out of the cavity due to the stack effect. During the winter, heat can be gained from the cavity due to the greenhouse effect. The final proposal uses external sun shading to prevent heat gain in summer, and at night the facade can be opened up to ventilate and cool the building. With these 3 design solutions in mind, we can now start with our individual facade designs.